Okay, here recording in progress. I'll share the screen. All right, so we're up to here. Okay. And I should be finished with 3.4 today. So if I just stop at 3.4, that's good enough, I think. So I have all these buffer days. And then we just have 3.5 and 3.6 leading up to the exam. Okay. So it takes some extra time to do these rational functions. So spending quite a bit of time on it. And 3.5, again, I'm shortening the assignment somewhat, skip 11 and 23 on, so that makes 3.5 a lot smaller. Okay, so I was going to do just 4 more problems. Let's see, 41, 35, 27, and 43. And then I was pretty much going to be done. And then I'll let you ask any questions. And if we don't have any questions, that's it. Once I finish those 4 that I was assigned to do on my list, and then we can just call it a day after that. Okay, so back to some more of these rational type functions. And let me show you 27. Okay, so again, this is a problem that has a hole. So I'm going to emphasize this kind of problem. Oops. Okay, so
you covered this problem yesterday.
Yes, I wanted to emphasize. Yeah, I wanted to emphasize something extra about it again. Okay, so yeah, we factor just because you have something like this. What I wanted to say is you don't necessarily have a vertical asymptote at x equals -1 and x equals 3. You have to wait and see if there's any cancellation. And indeed, we do have a cancellation, right? So this cancels out x minus 2 over x minus 3. But this is not really the original equation. This is the original equation. Okay, and what's the difference between this equation and this equation? Here, x is allowed to be -1. Here, x is not allowed to be -1. Right? Remember, we had a question on the test that said, what's the difference between these 2 functions? You know, it's just at one point, right? One x value, whatever it was not allowed for this one, but it was allowed for the other one. So that means -1 comma 3/4 has a hole. So the rest of the problem, I'm just focusing on x minus 2 over x minus 3. I did all my analysis over here, but I have to remember there's a hole at -1 comma 3/4. Okay, so my vertical asymptote is only x equals 3. And then I do my intercepts as usual. So if I plug in 0, I get -2 divided by -3, or 2/3. And then y equals 0. Remember, a fraction is 0 when the top is 0. I just look at the top. What makes the top 0? 2. So 0, 2/3, 2, 0. So that gave me this point and this point. Horizontal asymptote. You can just look at x divided by x, which is 1. So y equals 1 was a horizontal asymptote. Okay, if I plug in a super big number like a billion minus 2 divided by a billion minus 3 is practically 1. I don't need a calculator for that. It's roughly 1. And if I plug in -1 billion and 2 divided by -1 billion and 3 is still about 1. Okay, so if I go way out to the right or way out to the left, right, then we approach y equals 1. And then I just analyze what happens near my vertical asymptote, a little bit to the left. Yeah, so this x approaches either plus or minus infinity, y approaches 1. So if I go way out there or way out there, x is a little bit to the left of 3, 2.99. I get a negative, it drops down. A little bit to the right, 3.01 or 3.1. It's positive, it shoots up. So that tells me I have this and this, but I have to remember to punch a hole in the graph right here, -1 comma 3/4. I throw that out. Okay. So that's where we were. So in other words, you don't automatically get a vertical asymptote. If you look at this, right, you might just say, oh yeah, x equals -1, x equals 3, vertical asymptotes. Not if you get a cancellation. Okay, so we get a cancellation. X equals -1 is still not allowed, but it's not an asymptote. Instead, it's just a hole. It's a hole in the graph. Okay. All right, so let me go ahead and show you 43 now. 43. X squared over x squared minus 5x plus 6. Okay, factor x minus 2, x minus 3. No cancellation. All right, so x equals 2 and x equals 3 are both going to be vase, vertical asymptote. X equals 2, x equals 3. Intercept. What do you get when you plug in 0? 0. And when y is 0, x is 0. So the graph touches the origin. 0, 0. So va, vertical asymptote, x equals 2, x equals 3. The ha, y equals 1. How did I get that? This is second degree. This is second degree. Just look at the leading coefficients. 1 divided by 1, 1. So horizontal asymptote, y equals 1. If I go way out to the right, or if I go way out to the left, okay, the graph approaches y equals 1. Okay. So if I plug in a billion, okay, a billion squared divided by a billion squared, and then these things are puny by comparison, it's 1. Might actually be better to look at this. Okay. A billion times a billion, right? Divided by a billion, take away 2, billion, take away 3. It's back, it's still a billion squared, so 1. Okay, so I have an asymptote x equals 2. I have an asymptote x equals 3. How do I get the rest of the graph? So what happens a little bit to the left of 2, a little bit to the right of 2, a little bit to the left of 3, a little bit to the right of 3. So I picked 1.9, 2.1, 2.9, 3.1. Do my sign chart. Then I notice, hey, x squared. What do I know about x squared? Unless I'm plugging in 0, which I'm not, it's always positive. So right away, plus, 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 plus. All the numerators are positive, right? Even if I plug in a negative number, it'll be positive. Right? So they're all pluses. So the only thing I have to worry about is the bottom, right? So 1.9. 1.9 minus 2, negative. 1.9 minus 3, negative. 2 negatives. That makes the whole thing positive. Y approaches infinity. Okay, so a little bit to the left of 2, we shoot up. We have to touch the origin. And then we approach y equals 1. So that tells me right now it's going to go something like that. Okay, a little bit to the right of 2, 2.1. I already know this is positive. 2.1 minus 2, positive. 2.1 minus 3, negative. So that makes the whole thing negative. Y approaches negative infinity. So a little bit to the right of 2, the graph shoots down. And then analyze 3, a little bit to the left, 2.9. 2.9, I already know this is positive. 2.9 minus 2, positive. 2.9 minus 3, negative. Positive, positive, negative, 1 negative. Whole thing is negative. Y approaches negative infinity. So it goes like this, goes like that. So it must be the case where it goes up and goes down. Now, how do I know where it is? I don't. You'll learn that in calculus. I do know it does not cross the x-axis, because if it crossed the x-axis, I would have gotten that in my intercept analysis, right? But I already know there's only one intercept at the origin. So it goes up somewhere and comes down. Is it exactly halfway, like at 2.5? We don't know. We can't say that for sure. You'll learn that with techniques of calculus. I drew it that way, but it doesn't have to be. Okay. So you might say, oh, halfway 2.5, that must be the maximum point. It does not have to be that way. Okay. And how high does it go? I don't know that either right now. You'll learn that with calculus. Yes, question.
In reference to like a question like this on an exam, like in the text, it told us that it went through a horizontal asymptote at some point. Will that be the case for the exam, or are we expected to always check?
To expect that the graph passes a horizontal asymptote?
No, will you will you tell us, like, will an exam question be like, this graph passes a horizontal asymptote, or are we expected to just check if it does?
Are you expected to check that it does? I mean, by my graphing this, that already tells you that it passes the horizontal asymptote. So
yeah, I guess you're right. Yeah.
So I don't have to give that exact language, but yeah, that does emphasize the fact that just because you have an asymptote, see, some people think, well, if there's an asymptote, the graph doesn't touch the asymptote. That's not true. Here, we do touch the asymptote.
I see. Yeah, because of the 0.00, and because yeah, I see. Okay.
And so here, and it has to go up to infinity, so it has to pass y equals 1. For sure.
Thank you.
Good, you're welcome. In fact, at this stage, I really don't know that it doesn't go up. It might come up and then back down. We don't know that. Okay, it's just easier for me to go like that. And I will accept that on an exam. Those further analyses as to how do you know when it goes up and down, you'll get that in calculus. Okay, then the last thing I have is a little bit to the right of 3. So 3.1, looks like I got all pluses. Let's check. I don't have to check that. That's positive, right? Because it's squared. 3.1 minus 2 is positive. 3.1 minus 3 is positive. They're all positive, so positive. Y approaches infinity. So a little bit to the right of 3, it shoots up. Then end behavior, we approach the asymptote. So I drew it like so. And there we go. So that pretty much does it. All right, so any questions about this, please? You know, just for fun, I think I have the time. Let me actually punch in my calculator to show you the so-called big number or small number. It's probably easier for me. Well, I think I'll plug into the original. Where was the original? Right here. Okay, so a little bit smaller than 2 is like 1.999, something like that. So let me try to plug in 1.999 to the original. And I'll show you what I got. 1.999 squared divided by parentheses 1.999 squared minus 5 times 1.999 plus 6. Okay. Sorry. Let me get this focus. 3992. Big number. So there it is, shoots up. If I cross just a tiny little bit, I get a big negative number. So like 2.001. Okay, so let me try to type in the same expression, but I'll type in 2.001. Okay, 2.001. 2.001. 2.001. Negative 4008 point blah 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 blah. So a super big negative number, just as I anticipated. And yeah, you can do the same analysis here. I don't feel like it, but so if I typed in 2.999, I should get a big negative. And then if I typed in 3.001, I should get a big positive. Yeah. Okay. All right, that's that one. I had a request for 35. Let me show you 35. Just calculate out of my reader. Okay, so come up with a graph that does all of this. My screen is frozen, unfortunately. I have to stop share and try again. So when this happens, I have to try this, which may not work. It does not work. Well, so take a short break, folks, while I try to figure this out. Do something on your own. I have to unplug it and start over. Happens from time to time. It's okay. Ah, there we go. I think we're back in business. Yeah, I think we were here. $35. F of 2 equals 0. 2, 0. F of x approaches 3 as x approaches infinity. F of x approaches 3 as x approaches negative infinity. So when I go way out to either the left or the right, I go like so. Right? And then let's see, what else does it say? F of x approaches negative infinity as x approaches 0 from the right. F of x approaches negative infinity as x approaches 0 from the right, so it goes like so. And f of x approaches positive infinity as x approaches 0 from the left. Okay, shoot something like that. So I'm going to have an asymptote at the y-axis, which means x equals 0. So I put an x at the bottom. I got a 0 at x equals 2. So that gives me x minus 2 right now. But if I leave it like that, the horizontal asymptote will be x at y equals 1, right? First degree, the ratio is 1. I have to make it so that the ratio is 3. That's easy enough. Just put a 3 in front. So put a 3 in front of the whole thing, and that should do it. So f of x equals 3x minus 6 over x should satisfy everything. Okay, quick double check. If you plug in 2, you get 0. Yep. X equals 0 is not allowed. Yep. If I plug in a super big number, then minus 6 drops into insignificance. 3x over x is 3, correct? And likewise, if I plug in a negative big number, negative a billion, you can forget about that. The ratio is 3, and everything seems to work. Oh, and quick double check about the positive and negative stuff. If I plug in 0.00001, 0.001, negative divided by positive is negative. And negative 0.00001, that would be a negative divided by negative, which is positive. So yes, indeed.
Could you explain? So when you said that, so we have the vertical asymptote at x equals 0, right? And and you said that the x on the bottom is because that's like x minus 0, right?
X equals 0. Huh?
No, in your equation, it's the denominator is x.
Mm-hmm.
Right, so that's like x minus 0. So that's why the vertical asymptote is at x equals 0.
You could think of it as x minus 0 if you wish.
Okay.
Okay, so that does seem to satisfy everything. So that looks like my equation. Okay. And let's see, 3.541. I did get some requests, I think, for number 15, if I read the chat correctly. So let's see if I have time to do that. Okay, so let's see what I have here. 7, 43. Okay, so 41. F of x is x over x squared minus 3x plus 2. So that factors in x minus 1, x minus 2. No cancellations. Okay, so va, x equals 1, x equals 2. Ha, okay, first degree, second degree, right? The second degree is going to win, so automatically y equals 0. Okay. For super big X, the denominator is way bigger than the numerator, which means the ratio, if I divide that by that, I end up with essentially 0. Okay, so horizontal asymptote here, and intercept, origin, 0, 0. Plug in 0, you get 0. Okay, and then same thing, how do I get all the other stuff? All right, so I know if I go way out to the right, I approach y equals 0, x-axis. And if I go way out to the left, I approach the x-axis. Okay. And now near the asymptotes, do I go up to infinity or negative infinity or whatnot? So the only way to check is to plug in stuff. Okay, so near 1, a little bit to the left, 0.99. A little bit to the right, 1.01. All right, x approaches 1 from the left. 0.99 is positive. 0.99 minus 1 is negative. 0.99 minus 2 is negative. Positive divided by negative times negative, the whole thing is positive. So y approaches infinity. So it shoots up like this, touches the origin, and then gets close to the x-axis. A little bit to the right, 1.01. 1.01, positive. 1.01 minus 1, positive. 1.01 minus 2, negative. Positive over positive times negative, negative. So y approaches negative infinity. X approaches, now we analyze x equals 2. So x approaches 2 from the left, 1.99. 1.99 is positive. 1.99 minus 1, positive. 1.99 minus 2, negative. So this sign chart means the whole thing is negative. Y approaches negative infinity. So it again, it goes up to a certain point, comes down. How high does it go? I don't know. I know it does not touch the x-axis, because if it touched the x-axis, I would have gotten that from my analysis of the intercepts. Okay, and is that highest point going to be exactly halfway, like 1.5? I don't know. Maybe yes, maybe no. We can't tell. You'll learn techniques of that when you get to calculus. And I don't even know the y coordinate, right? Does this come up to -5, -7, -1? We don't know. It's just somewhere. Okay, then 2.01, looks like everything is positive. 2.01 is positive. 2.01 minus 1 is positive. 2.01 minus 2 is positive. Everything's positive, so y shoots to infinity. So there we go. The only point where the graph touches the x or y axis is the origin. Goes toward x-axis, shoots to infinity, negative infinity, positive infinity, and way out here we approach the x-axis again. So there we go. Okay. Okay, I was basically done. I did get a request from a couple students on 15. So I'll show you 15, and any other questions, feel free to ask. Otherwise, I think I'm done. Okay, so let's look at 15. So find a domain, intercepts, vertical and horizontal asymptotes, blah, 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 blah. Okay. So let me write this problem out. Clipboard here. Start here. Okay, well, you can't see the book, but I'll have to write it. So f of x is equal to x cubed minus 2x squared minus x plus 2 all over x squared. Find a domain, axis intercepts, vertical horizontal. Okay. And incidentally, this would also have a slant asymptote, right? And how do I know there's a slant asymptote? The degree of the numerator is 3. The degree of the denominator is 2, exactly one more. So if I do the long division, I would get a linear expression, x, and then plus some other stuff. So we would have a slant asymptote. All right. Oh, what can we do with the numerator? How about let's factor by grouping. Whoops. So in the numerator, I can factor out an x squared from the first two terms. X minus 2 minus 1 times x minus 2. You could also do your synthetic division, right? Rational root term, there isn't that much to try. You would try what? Plus or minus 1, plus or minus 2. Okay, but this one looks like you can be grouped, right? Remember, factoring by grouping, you factor x squared here. We have x minus 2. So how do I make this an x minus 2? I can factor out a negative 1. So then I can further factor out an x minus 2. X squared minus 1 over x squared. And this factors further x plus 1, x minus 1 over x squared. All right, so the domain, all real numbers except for 0. All real numbers minus the set consisting of 0. Okay, intercepts. Okay, when is a fraction equal to 0? When the numerator is 0. So 2, 0, negative 1, 0, and 1, 0. What else does it ask for? Okay, domain, got that. Intercepts, got that. Vertical and horizontal asymptotes. We know we have a slant asymptote. Okay, so there's no horizontal asymptote. Vertical asymptote, I got no cancellation. So x equals 0. Just focused here. Come on. Every now and then this thing. There we go. Okay, yeah. And the problem's finished. I'll dig a little bit deeper and say, how do you find the slant asymptote? Well, in this case, you would just do division. You could do the long division, but since the bottom's a monomial, you might as well just divide through. Okay, so that divided by that is x, right? That divided by that is 2. And just leave the rest of the junk alone. Okay, so that divided by that is x. That divided by that is negative 2. And negative x plus 2 over x squared is negative x plus 2 over x squared. So the slant asymptote, yes, I'm going beyond the call of duty here, is y equals x minus 2. Because for super big x and super big negative x, this drops into insignificance. Okay, so whatever this graph looks like, which I don't plan to do anymore, but here's, whoops, that's not what, x minus 2 is down here. Sorry. Okay, so way out here, the graph maybe goes like that. And way out here, the graph maybe goes like that. And I don't know what happens in between, but way out to the right, way out to the left, we approach y equals x minus 2. Okay. So that is that. Okay, and I'm done, folks. So I was actually done with this. So if anybody has a question, we can bring it up. But otherwise, I was finished with 3.4. Again, it looks like I'm behind in the schedule, but not really. I got all these buffer days. So even if I take 2 days for 3.5 and 2 days for 3.6, I'm still going to be good. Okay. So otherwise,
sorry.
I'm done with the section. Okay, yeah, question.
Could you go back to 15 and show me how you got from the group factored form to the f of x form?
Me to here?
Yeah.
Okay, this one, I just simply said, what's that divided by that? X, right? X cubed divided by x squared. Remember when you divide by a monomial in algebra? Dividing by a monomial, you can just divide into each one. So x cubed
Oh,
divided by
yeah.
x squared is x. Negative 2x squared divided by x squared is negative 2. And then negative x plus 2 divided by x squared is negative x plus 2 divided by x squared. Just leave that alone. So that tells me that this is a slant asymptote. Okay. All right, let me check the chat. Otherwise, I'm finished, folks, unless anybody else has something. Check the chat. Let's see, 3.415 was asked for. I just did that. So I think I'm caught up. Okay, so yeah, I said, I don't know if I want to switch back if possible, but yeah, I was done with 3.4. So tomorrow I'll start 3.5, it looks like. So anybody has a question on 3.4? Otherwise, we're done for the day.
Actually, for number 15, you mentioned that you would be able to do synthetic division. How would you do synthetic division?
Okay, how about I do synthetic division for that one? Oh, actually, I take it back. You're right. This one does not allow for synthetic. You can do long division, not synthetic division, because synthetic division, you can only divide by a first degree expression.
Oh, I see.
So it have to be x or x minus 1, but you can do this thing.
Oh, I see. Okay, thank you.
All right, you're welcome. You pretty much just get the same thing. So yeah. Anybody else please with anything? I'll have to stop share again and check the chat. I don't see anything else there. So, all right, any more please? Otherwise, we're done. All right, everybody. So we'll start the next section tomorrow, and everybody have a good day, and we'll see you next time. Okay. All right. Bye, everybody.